much you already know it, except for these sets. So you definitely want to write these down. It's just a different notation. So when you have an N like that, and it's got a double bar right here, this stands for the set of natural numbers. So natural numbers are 1 and up, with no decimals, no fractions. All right, so 1, 2, 3, 4, 5, okay, 1 and up. And then we've got this W here. So W is always 0 and up, and we call these numbers whole numbers. So that's a set of whole numbers. And you want to memorize what the different sets are and the symbols. Okay. Z is a really common one that we're going to see. So Z with the double bar, we have all the negatives, 0, and all the positives. Anybody know what we call those numbers? Yep. So integers are including the natural numbers, including the whole numbers, and all the negatives. Integers is still no fractions, no decimals, okay? And then Q is the rational numbers. So rational numbers includes fractions and decimals. P are irrational numbers. Anybody know an example of an irrational number? Pi. Okay, the square root of 2 is irrational. So it's a decimal that goes forever that can never be made a fraction. Okay, then we have real numbers. Real numbers are all of these. So real numbers include this, include this, include this, includes this, includes this. And then we have complex numbers. So complex numbers are also the same thing as imaginary numbers, like I. Okay, so that's when we get negatives under the square root. Those are imaginary numbers. All right, you guys got this written down? Okay, so this is the exact same problem right here, written 2 different ways. So we have x plus 2 is greater than 4, domain of integers. This is what we have done, and this is the exact same thing written in set builder notation. This reads x is an element of the integers such that x plus 2 is greater than 4, all right? So this symbol E means is an element of. And this bar means such that. Okay, so all we're going to do is solve it like we did before. X plus 2 is greater than 4. So we subtract 2 from both sides. So x is greater than 2. This is just a basic greater than graph. So if it's greater than 2, it's integers, meaning we're going to start where? At 3. And we're going to get bigger. 4, 5, and be sure you guys do your darkened arrow for the integers. All right, so this one reads, x is an element of, what is this one? Of the reals, such that the absolute value of x plus 3 is greater than 5. So, again, real numbers, meaning we're shading the number line, we're including all the decimals and fractions in between. So for absolute value of x plus 3 greater than 5, we would subtract 3 from both sides. So the absolute value of x is greater than 2. And then we have to show that it's two things. This means x is greater than 2, and it also means x is less than negative 2. And since our domain is real numbers, we have 0, 1, 2, negative 1, negative 2, open circle on negative 2, shade left, open circle on positive 2, shade right. All right. So this time we've got the brackets. X comma y is an element of the real numbers squared here, such that, and they give us the two functions. So this is how we saw it before, written like this. So the way we read it is the set whose members are ordered pairs of x and y, where x and y are real numbers, such that y is greater than x plus 2 and y is less than negative x. So this is exactly what you did before, right? We're still shading. We would graph the lines. Do you guys need to see this example? No. All right, you might want to write down this part here and maybe what this means, how you would read it. But you guys would graph a line with a y-intercept of 2, slope of 1, and both of these would be dashed lines, and we'd figured out where to shade. We'd be good to go. All right, this is a good one to practice. We've had some of these on our problem sets, and a few of you guys have missed these. So this reads x is an element of what? Good. Integers is the z, such that 3 minus x times x plus 3 is less than or equal to 0. So when we have these parentheses, right, we're looking at a quadratic. If we FOILed that out, you'd have x squared. So it's a quadratic. So there's two places that we want to break the graph. So my critical values are what gives me 0. So what value of x would give me 0 in the first set of parentheses? What'd you say? Positive 3. Good. If I plugged in 3, I'd get 0. And how about here? What critical value is this one? Negative 3. All right, we're doing integers. It's important to remember that. And because there is a line here, we are including our critical values. So let's number our number line. So I would have split my graph up by 3 and negative 3. We are doing integers, and we are including these points, but we're going to figure out if it's an OR graph or an AND graph by testing points. So if I plug in negative 4 right here, I have 3 minus negative 4. Is that a positive or a negative value? Positive. And if I plug in negative 4 here, negative 4 plus 3, is that positive or negative? That is negative. What's a positive times a negative? A negative. All right, in the middle, we're going to plug in 0. You guys need to show this on the test for full credit. So we're going to plug 0 in, and we're going to plug 0 in. All you have to show is this part here, okay? So what's 3 minus 0? Positive or negative? Positive. What's 0 plus 3? Positive or negative? That would be positive. A positive times a positive is a positive. All right, over here we're going to plug in 4 for x. So 3 minus 4, positive or negative? Negative. And 4 plus 3, positive or negative? Okay, a negative times a positive is a negative. Now, you got to check and see, what is this asking for? It is asking for values that are less than or equal to 0. So are we looking for the negative or the positive here? Negative. The negatives are less than 0. So that means we are going to shade this way. So we have an OR graph, and this way. All right, so always test a point in between each region.